Hi, today I'd like to discuss a few of the basics, some CAD terminology. First, what does CAD stand for? It's pretty self-explanatory. It stands for Computer Aided Design. This is where, like many things in this day and age, a computer assists us with something. So, the computer is assisting us or aiding us in mechanical design, architectural drafting, art. There are many different things this can be used for. But DesignSparck Mechanical is centered around mechanical engineering and mechanical design. Now, don't be afraid of the term engineering. We won't be doing a bunch of mathematics here. It's pretty straightforward. First, I'll use the interface to show you a few things. We have here the X, Y, and Z axes. And to explain those briefly, the X-axis, to look in front of a 3D printer or CNC machine, laser engraver, laser cutter, very, very similar. They all have these axes. We have X that runs left to right. We have Y typically running front to back, and Z running up and down. Now, if we go to a certain view here, you see it looks like graph paper. This is the construction plane. And the default construction plane in DesignSparck Mechanical is projected along the X and Y axes. So next, I would like to show you planes. Planes can be created for slicing, cutting, general reference, a bunch of things. So if we look in a 3D space, we have different planes. They're represented as just lines, pretty much, that attach together in a square to form a square. So if we go over here to Z, this is the plane that we can see from Z projected onto X and Y. We go to X, this is the plane that we can see from X projected onto Y and Z. And if we can make our way over to Y, we have the final plane in the group, which is viewed if we were on the actual axis of Y, looking towards X and Z. So it's projected onto the X and Z axes. We can go back into a three-dimensional mode again. And these, of course, I will teach you how to project onto planes later for reference or for slicing files, or slicing solids, should I say. So let's go on to the next thing I want to discuss here. Here we have points. If you were to get a pen or a pencil, get a piece of paper and mark a little dot on there. Technically, they're three-dimensional, but the third dimension is such a small scale that can't really see much. So if you're doing a two-dimensional drawing, you can have, say, X and Y, correct? So we're looking along X and Y, and we have a bunch of points. We have at 0, 0. We have one at 0 and approximately, or not 0, sorry. We have one at approximately 1.12 and 0.58. Here's another at 2.45 and 1.213, all the way up to here, approximately 4 and 6. So one thing that I forgot to mention earlier is how we measure these. It's just like graphing paper. We go right, positive. We can go up, would be positive, left, negative, down, negative. So we go here, we can count 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Now, if we were to put a point over here, and let's say a point over here, this would be 1. So X, 1, 2, 3, 4, 5, 6, 7, 8. So that's negative 8 because we're going to the left. And then Y, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it would be X equals negative 8 and Y equals 10. Now over here, we could go X, negative 1, 2, 3, 4, 5, 6, 7, 8. And then Y, negative 1, 2, 3. So this is how we count on the construction plane. Now these points, were we to, I want to show you something. These points, were we to go along the X-axis facing Y and Z, we still see the points. These are just for reference, as they have no real dimension. They're not three-dimensional, they're not two-dimensional. They have no depth, should I say. So that's for reference. Points are useful for a couple of things. You can connect points together, make different shapes. All right. Draw different things. This is completely off the top of my head. Say we wanted to make some kind of pool, a design for a pool or something crazy like that, or a custom shape, something we'd have trouble with using other tools. We could use points and connect them.